Hi, this is Algebra 2, Lesson 34. We're going to do more uniform motion problems. And these are going to be in the form of D1, distance 1, plus some number equals distance 2. We're starting on page 155. So far we have done equal distance problems where distance 1 equals distance 2. And we've done added distance problems where distance 1 plus distance 2 equals some number. When distance 1 equals distance 2, then rate 1 times time 1 equals rate 2 times 2, because rate times time is distance, right? When distance 1 plus distance 2 equals some number, then rate 1 times time 1 plus rate 2 times time 2 equals some number. Our new tweak is distance 1 plus some number equals distance 2. This means that one of the people or vehicles or camels or whatever traveled farther than the other one, whatever it was. So our if we draw out the diagram, they will look something like this. Distance A goes from the starting place to here. Distance B goes from the starting place all the way here, and the difference is 40 miles. So distance B went 40 miles farther than distance A. So A and B started in the same position, but A stopped, and B continued for another 40 miles. Or distance B started here and went all the way, and A started in the middle and finished in the same place. In both cases, distance A plus 40 equals distance B. So rate A times time A plus 40 is going to equal rate B times time B. Okay? Need to think these through. Don't be afraid to try the don't be too proud to try the diagram if they help you. Okay? Let's try a problem. Millicent began the journey at 6 a.m. at 50 kilometers per hour. Beauregard began to chase her at 60 kilometers per hour. What time was it when Beauregard got within 40 kilometers of Millicent? I actually copied this problem wrong, which is going to make it very difficult to solve. So let me read the correct problem. Millicent began the journey at 6 a.m. at 50 kilometers per hour. Beauregard began to chase her at 10 a.m. at 60 kilometers per hour. What time was it when Beauregard got within 40 kilometers of Millicent? Okay, it helps if I remember to copy things correctly. Alright, if we draw the diagram, this problem is not particularly well worded because it doesn't say that Beauregard and Millicent began at the same place. So we are going to infer from the problem that they did, because Beauregard is chasing her. It doesn't say he joined her or that they were a distance apart. So it should have said Beauregard started from the same place, but they are assuming that you are going to infer that. Alright, so here is Millicent. Millicent traveled that far. Beauregard is going to start at the same place, but he is going to stop, or our time anyway is going to stop, when he is 40 kilometers away from Millicent. Okay? So the distance of Beauregard plus 40 kilometers equals the distance of Millicent. So the rate of Beauregard times the time of Beauregard plus 40 kilometers equals the rate of Millicent and the time of Millicent times the time of Millicent. Okay? We know that the rate of Millicent is 50 kilometers an hour. We know that the rate of Beauregard is 60 kilometers an hour. We know, although since I copied this wrong, it's hard to tell from my writing, that Millicent began at 6 a.m. and Beauregard began at 4 a.m. So Millicent's time is also 4 hours longer than Beauregard's, since Millicent began sooner. So the time of Millicent equals the time of Beauregard plus 4 hours. Okay? So we're going to substitute these back into the problem, and when we get to the time of Millicent, we're going to put the time of Beauregard plus 4 into the time of Millicent, and that way we should be able to solve for the time of Beauregard and then figure out what time it was when Beauregard got within 40 kilometers of Millicent. So we have the rate of Beauregard is 60 times the time of Beauregard plus 40 equals the rate of Millicent, which is 50, times the time of Millicent, which is the time of Beauregard plus 4. Right? So we've got 60 time of Beauregard plus 40 equals 50 time of Beauregard plus 50 times 4 is 200. Let's get all the times of Beauregard on one side and all of the other numbers on this side, the other side. So we're going to subtract 50 times of Beauregard from both sides. And we can subtract this 40 from this side. This cancels and this cancels. We have 10 times the time of Beauregard equals 200 minus 40, which is 160. Divide both sides by 10, and the time of Beauregard is 16 hours. So if he started at 10 a.m. and he traveled for 16 hours, 12 a.m. plus 12 hours would be 12 p.m. So there are 4 hours left after that, which would make it at 2 a.m. the next day. So at 2 a.m. the next day, Beauregard got within 50 kilometers of Millicent. Okay, let's try another one. When the sheriff began his pursuit, Robin Hood was already 7 miles out of Nottingham. If the sheriff traveled at 6 miles per hour, while Robin Hood's rate was 2.5 miles per hour, how long did it take the sheriff to catch up? Okay, once again, the book is assuming that you will infer that the sheriff is starting from Nottingham. Okay, so the sheriff is starting at Nottingham. This is the distance the sheriff traveled. He's starting at Nottingham and he's ending at Robin Hood. Robin Hood is starting 7 miles out of Nottingham. So this is a distance of 7. And he's at least meeting the sheriff. Hopefully the sheriff is not catching him, because bad things could happen then. Okay. So the distance of the sheriff is going to be 7 miles longer than the distance of Robin, since Robin got a 7 mile head start. So the rate of the sheriff times the time of the sheriff equals 7 plus the rate of Robin times the time of Robin. Their time is going to be the same, since we are beginning when the sheriff started pursuing Robin and are ending when he catches up to Robin. So the time of Robin equals the time of the sheriff, which means that we can drop both of the subscripts for T, and we're just going to use T. the rate of Robin is 2.5 miles per hour, and the rate of the sheriff is 6 miles an hour. Okay, now we can plug these back into the problem and solve for t. So we have the rate of the sheriff is 6 times the time equals 7 plus the rate of Robin, which is 2.5, times the time. So we have 6t equals 7 plus 2.5t. We subtract 2.5t from both sides. 2.5t. Okay, we have 6 minus 2.5. 6 minus 2 is 4, minus another half is 3.5. So 3.5t equals 7. Divide both sides by 3.5. And 7 minus 3.5 is 2, because 3.5 times 2 equals 7. So the time equals 2 hours. It takes the sheriff only 2 hours to catch up with Robin Hood. Hopefully Robin Hood has some cool trick up his sleeve to get away. Alright, that is it for this lesson. Try your practice problems, do your homework, let me know if you have any questions. Thank you.